I'm going to be talking about decentralized authorization, plumbing, and permissionless operation. One of my all-time favorite quotes about distributed systems is that the limitation of local knowledge, the fact that data and information in general lives in a particular place and can only move at the speed of light, is the fundamental challenge that we have to contend with, and increasingly in the industry sort of in general. My name is Zelenka. You can find me anywhere on the internet as Xpeed. I'm the co-founder and CTO at a company called Fission, where we're working on tools and protocols for Edge and Web3 apps. And I work on a whole suite of things. I wish that we had more today to say about the interplanetary VM, which is essentially a AWS Lambda competitor that we're starting to work on. Also, private data with web native file system and dialogue, so file system, database, and UCAN, which I'm here to talk about today. And I'm the editor of the UCAN spec. It's being used by a bunch of companies, but I guess that means that I'm, despite not being the only one designing this thing, I might know a thing or two about it. So in Web3, broadly, we're now talking about doing nothing less than connecting all of the world's users and services in an open, interoperable way, which is something that we haven't seen since HTTP, right? TCP/IP, HTTP are pretty much it. And then we've waited now 30 years to get any more innovation on things that are open, interoperable, and everywhere, right? For all this stuff to work, just like David was just saying, this all has to be substantially better than Web 2, right? It can't be just decentralized. We have to actually make it work for real workloads, for real people today, faster, ideally cheaper. We want to get that whole triangle done, right? So how do we power a new internet? The internet, as I just mentioned, is about 30 years old and really comes from an era where your cell phone had a telescoping antenna that you had to pull out, right? Where all of your compute happened on a beige box under your desk that didn't have the power to run anything, and that you always had to talk to essentially a mainframe, right, to get results back. That's no longer the case. But we still have to now contend with the fact that there's locality, and especially data locality. So as we know, obviously from physics, you're stuck in a light cone, right? And even if we send messages or data between things, that can only move so fast and only over such a certain size of pipe, right? So even if I send messages in multiple places in giant scare quotes, the same time, they still may arrive in different order and can only move so fast. Once you have enough gravity of data, they literally can't move it fast enough around because of physics. This isn't something that we can solve with fancier computer science. So we're here because we want to do compute over data. So in order to do any kind of compute, you obviously need data. And to do data in production, you have to have some kind of auth. So talking about auth today, it's a little strange in some ways to talk about auth in a compute setting. But in order to do any of this stuff, you have to have auth. Typical picture today looks something like this. You have a developer. They want to interact with some services. Maybe some of these have access to data and the others don't. And they'll connect to one of these. And then maybe these are all networked together so that they can get access to that data, right? And so each of the services have to have individual agreements with each other. And the developer has to pre-negotiate some tokens with all of these. But this isn't what we want, right? This is just how it happens to work. And with things like content addressing, we can liberate this picture from needing access in a particular place, right? We've made it now universal location. And with capability models, like what we're going to talk about today with UCAN, we don't need pre-negotiation either. So we can just move and freely move around both the compute and the data around a network. Historically, people have used things like OAuth to solve this problem. This is a typical OAuth flow. It has four agents in here from the user, the authorization server, etc. And it's, I'm trying to remember, it's like maybe 10 or 12 steps just to get through here. And this fundamentally places things in a certain location, right? You have to have an authorization server that says, here's the list of who's allowed to do what, right? By comparison, if we use capabilities, we can make this picture much, much smaller. And this is actually being generous to OAuth, right? It could actually be just 2 of these arrows and nothing else. And in an ideal world, auth should be just boring, right? So this is using capabilities, but it looks just like a regular, sort of like a Google login style. Yep, I want to give access to these, bits of data or this, compute resource, and are you sure you want to do that? Yep, and then you can jump right into the application. So I've said this word UCAN a few times. What exactly is it? UCAN is a user-controlled authorization network. If you're familiar with DIDs and public keys say who you are, and UCANs say what you can do. And this is the distinction between authorization and authentication. They look like this. The default encoding is just a JWT. So it moves around as a base 64 string that decodes to just some JSON. It is a different auth model than what most people are familiar with. ACLs have been around since at least the 70s, and it's just a list that says who's allowed to do what, as opposed to capabilities, which act a little bit more like a ticket. So we'll look at that in a little bit more detail. So here's some user, and they want to access some service. And they send a request that gets stopped by another process, that's essentially the bouncer, right, or some guard, who checks their list, and then maybe, if that user is on the list, will be allowed in. And this is, on one hand, nice, because it's broken up into these separate segments, but both it puts these two, the ones that are actually interacting, not in control. It puts this process in control, which means that you need to have this list in one place. And so you're stuck now with auth locality. You always have to go, and you're always contending with the speed of light to get this to move around. Further, if you can gain control of this deputy, sometimes it's called, you can do whatever you want, right? You have a system admin go bad and do whatever they like. And that's because they're the fundamental ones that are essentially the super admin for the system, not the service, not the user. Sometimes capabilities, by contrast, are kind of like tickets to go see a movie. When you go to see a show, you just know where it is, you're given a ticket, and they don't know who you are. You just hand it to them on your way in, right? So it's just this admit one. These are in control. You can carry the ticket with you as you're walking around to do your various things. If you can't make the show tonight, that's fine. You can hand it off to somebody else and say, you know what, go see the movie instead. Where the metaphor breaks down a little bit is you can make copies of these if you need to, and you can delegate sub-rights inside of it to someone else, which would, in the movie scenario, I guess, be if you had, say, a movie festival pass, you could delegate, you can go on Tuesday, but not the whole thing. If you come from a blockchain background, these are a little bit like state channels, but for auth. And they can do some things for composition that ACLs don't. So rights amplification is the composition of your authority across multiple systems. The metaphor that's always used for this is if you have a can of soup, you can't do much with it, and if you have a can opener, you can't do much with it, but if you bring them together, you can have a delicious soup. So if you have auth to read some private data and to do a computation on completely different systems, you can compose those now without having to pre-negotiate both systems. You can just say, hey, here's a certificate that says go read from over there, take this thing and run it, and that's it. To get right down to brass tacks, this is how an actual certificate looks. It has a header, just like a regular JWT. It has this payload, and then a signature. And the signature has to match the issuer, which is contained in the payload, so that you can prove that this is who it came from. It has a description of what you're interacting with, or what you're granting permission over, and what you can do with it. And that's openly extensible. There's nothing in the system that says these are the things you can do. You can define completely your own, as long as the other service understands what that means. And this is just, a noun and a verb. That's all. And they're fully extensible, right? You can add sort of whatever other data you need as well. So in this case, we're saying you can only send emails to people at a Fission Code's email address. This is also, whoops, that's right. This is also all the information you need for invocation. So you don't actually need a separate system now to say, and please run this, right? It's, hey, do this thing, please run this WASM over this data. And it can be both the auth and the invocation call. So you can do distributed RPC as well in the same model. You probably don't want to invent your own whole set of resources and abilities. So there's a standard library for a bunch of the really common ones like mail servers, file systems, et cetera, and sort of your CRUD actions and so on. And you can take those and make them even more powerful by saying, okay, I have a read capability out of the standard library, but I'm a photo application and I want to narrow that down further to publishing into an album. You can just define that, and anybody else that you're collaborating with just needs to understand what album publish means, and that it is backed by this read action, and everything works. The way delegation works in the system is you have a chain of who originated the resource all the way down to who's consuming it, as long as the resources and actions get narrower as you go down, right? So if I have the ability to write into an entire file system, maybe I can give somebody else access to write just into the documents folder. So by creating a resource, I have full access over it. I'm the admin. I can then point to, hey, this is from me to somebody else with some subset of my rights, and then they can do the same thing. Hey, here's to somebody else and a subset of those rights, and so on. And because we can follow this chain backwards from this last invoked one, they contain all of their parents, or at least references to all of their parents, there's content addressed. We can verify this anywhere. It doesn't have to be at a particular place. I can just walk around with it. This works offline. This even works in the browser. So with things like WebAssembly and offline compute, you don't necessarily need to go to an external system. We can keep stuff completely off the network in a lot of cases and not have to deal with that 200 millisecond round trip time. So all of the browsers now have Web Crypto API, which means you can have non-extractable keys. Public-private key pair, where the private key isn't viewable to anyone. It's completely managed by the system, never leaves the system, doesn't move around. And we can link between them now in a perfectly secure cryptographic way that still preserves user agency, data locality, and reduces the amount of stuff that we have to put on the network. If I'm going to run a query over a database, we have content addressing. I can pull down the subset of the database I care about, run queries over it, make some updates, and then atomically push the diff, for example. So plugging things together, plugging together services, plugging together applications. Perlis said every program has at least two purposes, the one that it was designed for and the one that it wasn't. And we want to enable all the things where people didn't expect to plug things together. So here's a user who's signing in with MetaMask and an Ethereum account. And they have a bunch of these, these emoji are representing different resources and actions that they can do. And she wants to collaborate with this other person and says, you know what, you can manage everything for me directly in Chrome. And he says, you know, I actually also need to use this on my iPhone, but you know, sometimes I leave it out, so I'm only going to do some subset of things on that. So delegates between devices. So this isn't per person now, this is per software agent. And can delegate that on further to somebody else working in Brave. But it doesn't have to go in this direct chain, right? You can delegate as many times as you like. So here on Polygon, right, a completely different set of capabilities as is across the top. And a WebAssembly function in the cloud. And finally, somebody working in Firefox can take these two, you know, farther down the chain and bring them together and now have access to both. These aren't limited to a single application, right? Maybe there's Twitter at the top and a spreadsheet application on the bottom left and some science app on the bottom right. The certificate doesn't care. And we can plug these systems together now without having to worry about, well, you know, what is Twitter's token format? Or, you know, I mean, Twitter hasn't adopted UCAN yet, but in this glorious future, we don't have to worry about what their specific API looks like, what their specific token format is. We can just attach all these things together like Lego with zero coordination ahead of time. People usually ask about this time like, well, okay, that's great. You have all this stuff moving around the system. How do I revoke things? And the good news is we have content addressing. So as long as you're earlier in the chain, you can sign a revocation and gossip that through the network to say, hey, you shouldn't trust this specific one and anything downstream from there. So if this guy, you know, on the Chrome browser revokes this Brave browser user, but not the one in the middle, the downstream consumer of that also can't use it. So let's look at a non-trivial example. This is a relatively complex UCAN, right? It's, lots of random-looking letters and numbers. And I won't go through like every layer of it, but just to give you a flavor. Here is that same token format that we looked at a little bit ago. And it has two proofs in it. And these are just other base64 encoded UCANs. This is actually, I'm inlining it here, because these are actually CID pointers to them, but this is actually what's happening under the hood. And then we can take one of those, so this purple one, and unwrap it, and look inside and say, okay, great. On this previous one, I have the ability to append into a photos directory and into a notes directory. And one of my proofs gave me the ability to append into photos. So I'm always narrowing down or at the same level as my proofs. People started building a bunch of tooling around this stuff as well to help explore all of these proofs and the proof chain and what is this UCAN actually able to do, and is the signature valid, and all of this stuff. It's a little application at ucan.xyz, and basically you can just paste one in and it'll decompose it for you and say here's all the moving parts basically. And then to explore all of the proofs in the delegation chain, you can click through along the bottom, this one has 3 proofs, I want to see proof 1 or proof 3, and you can drill down into the chain. So it's still extremely, extremely early days for Web3. We're just figuring this stuff out, right? I would say that we're about here, right? We're not even at the classic chasm, we're at the smaller chasm. But it's growing fast. And if we're going to compete with Amazon and Google and Azure, we need to find ways of plugging our stuff together. We don't even register in scale, right, against them yet. We want to find ways to leverage everybody in this room, all those smart brains in here, right, and everybody's projects and efforts to not need to reinvent the wheel every time and have a winner-takes-all mentality, right? We have content addressing. We can move things around. We can push compute to particular places. At the end of the day, in Web 2, service composition is too hard for devs, DApp UX, and I would argue that a concept of DApp doesn't even exist. You have applications that users use, right? DApp UX is too hard for people, and no one today is in control of either their data or their compute. And we want to put that directly in users' hands or the service provider's hands directly without having to always go through one of these giant systems. We're building on top of standard, well-understood technologies to be a Trojan horse and get it in basically everywhere. One of the teams building a tool for thought on top of UCAN said that they really love this, that you can encode it as a JWT because it works with all of their existing tools, right? It plugs right into their Rust server as a bearer token in the header, and it decodes it for them. Yes, they then have to plug it into a UCAN library to actually understand what's happening inside of it, but the actual ingestion pipeline just works straight out of the box. They're in a sort of a Web 2.5, but there's nothing saying that you couldn't do this in a pure Web 2 space, and we want to connect Web 2 and Web 3. I'd recommend in general for everyone here, also echoing a bunch of the things that David mentioned earlier, we need to play nice with others, plug into existing systems, bridge into existing standards, and make it easier, more secure, and more open than existing systems, than OAuth, X509, SAML, MetaMask, Wallet Connect, all of these things. Further resources. We have a bunch of sub-projects. If you do an implementation, we will commission a logo for you. We do a lot of work on specs and improvement proposals. We have implementations in TypeScript, Rust, Go, Haskell, and there's private ones that are not, unfortunately, in the repo, but are being used by people in Elixir and, I believe, Python. There's an IPLD implementation from the good folks at Daghouse, which is powering big chunks of their system internally, to the point that their services in their service mesh don't know that they're running as part of a trusted execution environment or something. They just communicate with UCAN and read certificates and say, okay, great. And if later they decide that they need to collaborate with a mail provider or some sort of heavier compute, they can just do that. Their system doesn't need to understand anything special. We've also extended this to things like establishing mutual TLS channels. So if you want to collaborate with a bunch of other people that have access to the same kind of data, they can prove to each other, hey, look, I have this certificate. I'm not going to delegate it to anybody, but I have this certificate right now. I can sign a challenge with it. Let me into the, give me a key so I can communicate on this channel. We do instant messaging, all of that stuff. Coming up next, we're getting to a V1.0. So we've been at this for about 2.5 years now. On the last community call, we run monthly calls. A few people said, hey, it'd be really good to get this to a 1.0 so that we know this is like the long-term supported version. We're plugging into Sign-in with Ethereum. WhoCan is a proposed replacement for IPNS that's based on top of UCAN, so a DHT for naming. Invocation, so actually agreeing and aligning on a UCAN invocation spec that gives both the authority to run something as well as to say, hey, please run this specific action for me, which is largely being driven by the Daghouse use case, though we also have uses for this inside of Fission and IPVM and a bunch of others. We're doing state channels with these, so you can do payment directly in a UCAN, and cosigners, so you can do multi-factor authentication, things like that. I've already actually talked about the invocation, so UCAN is RPC. The vision there is that this could essentially replace a gRPC-like interface and have it come along with the auth as well. Because this is going to be on video, and people often ask for resources, here's a set of links. Thank you. And do we have time for questions, or? Yeah? Okay. Yes.
Oh,
sure.
So, made a note here. So when you were talking about revocation,
Yeah.
it seemed to me like it was revocation can be done after the fact, but can you do revocation before the fact? In the sense that I don't want this particular entity to access any of this before that. Also things like limits in the number of invocations or not allowing delegation. Basically, negating stuff before the fact. How do you do that?
Yeah, so limiting number of invocations, or you're not allowed to delegate further past, this depth, things like that. All of that requires some central place that you're going to check that list. We've tried with various, getting clever with hash preimages, all of this stuff. At the end of the day, there's always some way to get around it. So that has to be handled at a place. And so you can actually plug this into systems like CapTP that say, okay, this is the resource that you're going to access is essentially a proxy that will then forward messages on. And so you can do all of your offline delegation and then pass it off to this central service, and then it can keep moving, basically. So that does force you into location and locality again. So it's not the general case. You can do it. And especially enterprise use cases are often interested in that.
I have a question as well. It's
Yes.
somewhat in the same direction, but
Yeah.
It's pretty common to have a situation where you may have a substantial amount of data that if all of it were present at once would be able to yield quite a bit of information about you. So you may delegate only portions of it. But given the system allows recombination of data later, how do you prevent this from happening?
Right.
Like if you specifically shard things out so that this doesn't happen, other people can just be like, oh wait, there's all these pieces, I'll just put them back together, right? How do you avoid this?
Yeah, totally. So the core, like UCAN itself won't unless you use a system like this where you're pushing things through some coordinator, right? That says like, yep, sure, yeah, you can get this, you can't, and tracking, actually IDs. There's two layers when we talk about private data. There's encryption, so you can do encryption at rest, especially in content at rest data. And I would strongly, strongly recommend that because data can now move around the system. And not just while it's in transit, right? Like when it's actually being stored in multiple locations, you don't necessarily trust everyone that's storing that, right? And then retrieval is the other layer, right? So we have access control at the network layer and at the data storage layer, both. If you, it's sometimes easier to think about this in terms of the keys. If I give you a key to one directory and a key to another directory, obviously you can get into both of them, right? So part of the idea here is, depending on how open your system is, if you're allowing any entity into the system, then there's no way around this, right? You're kind of stuck. If you have some blessed group of DIDs that are allowed to actually access things, you can push them through a CapTP system. Just sort of the short version of this. So, yeah. Great.
Yeah, I got a question here. How do you manage in open permissionless systems? Right here.
Yeah. Okay.
Off-chain systems that the verifier is actually not malicious.
That the verifier isn't malicious.
Yeah.
The verifier is the one that's doing the
backchain trace of the permissioning.
So they're the ones that are actually executing things. So it's in their best interest to not, like, they can only hurt themselves, really, right? The verifier isn't external to the system. You're handing it directly to the service to say, hey, check this chain, which is signed cryptographically, and only execute it then. If there's a bug in your code, then yeah, it could do something wrong, potentially.
So the entire system is fully object-oriented. Is that in the sense that the verification is part of every service implementation?
Yes.
Access, okay, gotcha.
Yeah.
One more question about, I think you called it the verb. I'm not sure. It was the way that you described sort of these actions. You mentioned kind of in passing that people have to agree on this. How do you cause that agreement to happen?
So there's a standard library for most things, right? It's openly extensible. So in any standard, the spec describes the minimum number of things that we can all agree on that every implementation will understand. And if you invent some completely random other thing, you're narrowing who you can interact with, and it has to only be with them.